I am Michihiko Ueno from Machine Learning Research Team, and I will be presenting AI filter assistance in video call systems. Recently, anyone can post videos on social media or do live streaming, and the demand for video communication such as video chat has increased. In addition, the trend has been accelerated by the global COVID-19 pandemic, which has brought about a new normal. Under such circumstances, video communication services from various companies are being used for formal purposes such as teleworking and seminars. But video chat isn't just for formal use, such as online meetings. Video chat is also being used widely for casual purposes such as online drinking, online homecoming, online partner matching, and casual chats in a private way to share time with close relationships. This is a mapping of popular video streaming and video chat services by the way they are being used. The services are categorized with the scale of casual and formal on the vertical line and private and public on the horizontal line. Casual and public on upper left include one-to-many video sharing services such as TikTok and Instagram and Line Live. In lower left, there are public and formal business and seminar usage like webinars. In lower right, services for private and formal usage include Microsoft Teams, which is often used for business. Zoom and Skype are also being used for business, but also are being used for online drinking and casual and private purposes. However, as casual and private video chat, Zoom and Skype do not have entertainment features of TikTok and Instagram. We believe that visual effects such as AR filters are the key to adding more entertainment to new use cases of video chat. Therefore, we are working on a project called Masquerade, which promotes casual and private communication using AR filters. The effects of the AR filter are to decorate your selfie, to entertain people and yourself like in TikTok and Instagram, and to mask your face and background by replacing with characters and different sceneries. These AR filters are used for icebreakers to start conversations and to play games with the person you are talking to. In this way, AR filters that can give various effects to yourself on the screen and enrich communication between users will be important visual effects that promote communication in video chat, like stamps in line chat. Therefore, we are focusing on AR filters to enhance the entertainment element of casual and private communication. However, a number of cumbersome operations are needed to use AR filters during video chat. As you can see in this video, first you have to hold your smartphone and touch the screen during the video chat. Then you need to launch the AR filter menu and keep scrolling until you find the filter you want to use. If you can't find the filter that you want to use, you have to go back and forth between the menus. If you don't like the filter you selected, you have to scroll through the menu again to select filter again. Such interactions divert the user's attention to the filter selection, disrupting the ongoing conversation. I would like to now talk about Masquerade, a project to apply AR filters using gestures and speech recognition, with the aim of applying AR filters without disrupting the conversations and users' attention. Users do not have to open a menu to select an AR filter, but can select it with physical gestures or gestures on the screen with speech. In response to the operation, the system immediately chooses the AR filter that the user wants to use and reflects it on the screen. This research is in collaboration with Professor Koji Yatani of the University of Tokyo, supported by the Center for Robust Intelligence and Social Technology. Please watch the demo of our early prototype that we are developing. Cat. illustration. Cat. Did you see in the demo that the types of AR filters changed with physical gestures and speech recognition? In this system, we are designing user interaction to solve two problems of where to apply the filter and what filter to apply. Where to apply the AR filter is specified using physical gestures. In the demo, when the user points to his face, the AR filter is applied to his face, and if he points to the back, the AR filter is applied to the background. Manually wiping the front of the face is the interaction to remove the AR filter. To recognize where the user is pointing, AI technology is applied to estimate the posture of hand and fingers from the camera image. It recognizes the shape of the hand and detects where the index finger is pointing and decides where to apply the AR filter. We are currently developing a gesture that applies an AR filter not only to your own face but also to the face of the person you are chatting with. On the other hand, speech specifies what AR filter to apply. In the demo, commands such as cat and illustration were given. Even if you use the same gesture of pointing your face with your index finger, different filters will be applied according to different speech commands. Pointing to the background and saying cat applied a virtual background with cat illustrations. The speech command incorporates speech recognition technology. By combining these two AI technologies of speech and gesture recognition, you can easily and instantly apply an AR filter without touching the screen. In the demo system, the two types of AR filters are applied. We studied existing AR filters and divided them into three types. First is a person-centric AR filter used for selfies, such as making yourself an animal or illustration or distorting your face. Second is a background-centric AR filter that affects the entire screen, like a virtual background or a color tone of the camera. The third is others, such as playing games or showing your face and body in an artistic CG video. In this early prototype, we proposed an interaction method for selecting person-centric and background-centric AR filters, which are widely used. The interaction design we are proposing is the concept of user applying the AR filter through user operation. Going forward, we will do research in order to advance this further and allow for more comfortable switching of AR filters and the validation of the effects. For example, we would like to design an interface for exploring more complex AR filters, improve the algorithm for selecting AR filters, and do user experience validation using the prototype. Let me summarize. I talked about our project Masquerade, which allows users to quickly and easily select AR filters for the casual visual chat with friends in the new normal lifestyle. In Masquerade, we designed an interaction that uses gesture and speech recognition to select AR filters, and I showed a demo. Thank you very much for your interest in this project.